Here we have a quadrilateral ABCD with two green sides which are of equal length. We also have a diagonal BC in it, and we know three angles in this quadrilateral: 70 degrees, 35, and 25 degrees. And we are asked to find this angle X. Now there are several ways to solve this problem, and I know some ways that are probably faster than what I'm going to talk about today, but I'm going to use this example to discuss something else I wanted to discuss for quite some time, and that is congruency criteria for triangles. So when I look at the problem like this, I see something that closely resembles a trapezoid for me. So what I'm going to do, I'm going to actually create a trapezoid here. And not just an arbitrary trapezoid, because we have these two green sides here. So let's keep them green. And we're going to get what's called isosceles trapezoid. And that's a trapezoid that has two sides of the same length. We connect point D and E here. The next thing we need to know is something about isosceles trapezoid, and that is the angles at the base should be the same: angle A and angle C, and angle D and angle E. Since A is 70 degrees, C also has to be 70 degrees. And since this is 35, this is 25, this angle right here should be 10 degrees. Well, now if you look at this triangle CED, this is an isosceles triangle. Angles at the base should be congruent, and they have to be 85 degrees if you want all angles in the triangle to be 180 degrees. The next thing is the fact that AC and BE are parallel to each other because it's a trapezoid. And if you look at angle A and angle B of the trapezoid, those angles are what's called same side interior angles for parallel lines, and those angles should be together 180 degrees. Same goes for angle C and angle E. And because of that, this angle B and angle E should be 110 degrees. And since this big angle E in trapezoid BEC is 110 degrees, and this angle right here DEC is 85 degrees, it means that the small angle right here BED should be 25 degrees. Now if we look at the triangle ABC, we know 2 out of 3 angles, so we can calculate the third one. It's going to be 75 degrees. Now if you remember, this big angle here for the trapezoid was 110 degrees. This angle is 75 degrees. Therefore, this gray angle here should be 35 degrees. But now, this angle is 35 degrees. And if you look at this angle, it's 25 plus 10, it's also 35 degrees. Now let's look at this green triangle BEC. We have 2 congruent angles in this triangle. Therefore, this is an isosceles triangle. And that means that BE equals to CE, and that means that BE should be a green line. Now let's consider this purple and this peach triangles. They have many things in common. Both of them have 25-degree angles. Both have these green sides. And they also share this red side. So they have 2 sides and an angle. And we know there is a congruency criteria that involves 2 sides and an angle. However, these triangles don't look congruent. And they don't look congruent because they are not. And that happens because the criteria we're talking about, criteria called SAS, is a criteria for 2 sides and angle between them. In our case, the angle is not between them. So this is the case that is often called SSA case. but it's actually more fun to pronounce it backward. But what's happening in this case, we have this angle gamma, and we have two sides, side A and side C, and this angle gamma is not between the C and A. The reason why this is not a congruency criterion is because there are actually two ways to put this red side C. One way you see here, another way you see here. If it were a congruency criteria, there should be only one way to create a triangle. But here we have two ways. Although we don't have a congruency criterion here, we still have a certain relationship between these two triangles we got. And in particular, there is a relationship between these angles alpha and beta. And to see the relationship between this angle alpha and angle beta, notice that we have an isosceles triangle with two red sides, and the angles at the base of the isosceles triangles are congruent, so this angle is also alpha. But now notice that this angle alpha here and this angle beta here together gives us a straight angle, which is 180 degrees. And that's the relationship that we have in these two triangles, and that's the relationship we're going to use in the solution of our problem. It turned out that this SSA situation could be a criteria of congruence. But for that to happen, there are certain conditions on the sides and angle should be satisfied. First of all, you do have congruency when angle gamma is greater or equal than 90 degrees. So once you specify the angle gamma, you got the green side, then you'll find that there's only one way to put the red side. But even when gamma is less than 90 degrees, there are still situations when we have a single triangle, when we do have a congruency. And that's the case when side C is greater or equal than side A. Now this condition is automatically satisfied for gamma greater or equal than 90 degrees. But it's not always true when gamma is less than 90 degrees. But when it is, like here, there's only one way to put this red side. Because if you try to put it in some other way, we'll have to go here, and that's not really the triangle we're dealing with. Now let's go back to our problem right now. In that situation, we really have the first case when we have two triangles. And let's try to use this condition that we have for the angles of those triangles. But before we use this formula, we want to make sure that we are dealing with two different triangles right here, so that the purple triangle and peach triangles are not congruent. They do not look like congruent triangles, but nevertheless, we need to check. So how are we going to check it? Well, first of all, let's look at the angles like alpha and beta right here. For those triangles we're dealing with here, those are the angles between the red side and the black side. Same goes here. For the purple triangle, it's going to be angle X. That's between the red side and the black side. But for the peach triangle, is this angle D, BDE. And to see that those two angles are different, first of all, notice that this big angle B between the green and the black line is 35 degrees, and this angle X is a part of it. So X is actually less than 35 degrees. On the other hand, when we talk about this angle BDE, we see this angle from the peach triangle is 180 minus this angle E of 25 degrees and minus this angle B. And this angle B right here, EBD, can be calculated as this big angle of 35 degrees minus this angle X. And we're going to get this angle BD is 120 degrees plus X. Since x is positive, the angle BD is more than 120 degrees, and obviously that is different from the angle x, which is less than 35 degrees. So those angles are different. We proved that peach and purple triangles are not congruent, but in this case, the only thing we have is the situation like here between angle alpha and beta. So really, since x is less than 90 degrees, x will be similar to alpha, and angle BDE will be similar to angle beta. But together they should give us 180 degrees. So now we got actually two equations for angle BDE and for x. This is one equation, this is another equation. And what we're going to do, we're going to take this equation and subtract it from this equation. When we do that, angle BD is going to cancel out, and we're going to get an expression like this, which we can simplify and get the final answer as x equals to 30 degrees.